Q6835-2, which maneuver would cause the unloading the rotor system and result in a possible power pushover? A. During a steep descent. B. After a pushover from a steep climb. C. Just prior to landing. The correct answer is B. Performing a pushover maneuver from a steep climb in a gyroplane can result in unloading the rotor system and potentially lead to a power pushover. A power pushover refers to a sudden and significant nose-down pitching moment experienced by the gyroplane. It occurs when the rotor force is removed or significantly reduced, causing the aircraft to pitch downward. Unloading the rotor system refers to reducing the load or lifting force generated by the rotor. In the given scenario, when a gyroplane performs a pushover maneuver from a steep climb, it involves transitioning from a steep climb attitude to a nose-down attitude. During this maneuver, the lift generated by the rotor is reduced as the aircraft pitches downward, potentially unloading the rotor system. The sudden reduction in rotor force can lead to a power pushover, where the gyroplane experiences a rapid and uncontrollable descent. On the other hand, during a steep descent or just prior to landing, the rotor system is typically still loaded, and there is no sudden unloading of the rotor that would directly lead to a power pushover. Therefore, in this context, the correct action that may lead to a power pushover is performing a pushover maneuver from a steep climb. Q6835-3. If the gyroplane CG is below the propeller thrust line, which direction will the application of power cause the nose to move? A. The nose will pitch up. B. The nose will pitch down. C. The nose will not move. The correct answer is B. When the center of gravity, CG, of a gyroplane is positioned below the propeller thrust line, applying power will cause the nose to pitch down. In a gyroplane, the propeller thrust line represents the direction of the force generated by the engine's power. When power is increased, the thrust force pushes the aircraft forward, creating a torque effect. This torque tends to rotate the gyroplane's nose downward. With the CG below the propeller thrust line, the weight distribution of the gyroplane is such that there is a greater moment acting to pitch the nose down. As power is applied, this downward pitching moment is further amplified, causing the nose to move in a downward direction. Therefore, in the given scenario, when power is applied to a gyroplane with the CG positioned below the propeller thrust line, the nose of the gyroplane will pitch down. 6622. Which statement is generally true regarding wing camber of a glider's airfoil? A. There is no camber on either the upper or lower surface of the wing. B. The camber is the same on both the upper and lower surface of the wing. C. The camber is greater on the upper wing surface than it is on the lower surface of the wing. The correct answer is C. The generally true statement regarding wing camber of a glider's airfoil is that the camber is greater on the upper wing surface than it is on the lower surface of the wing. Camber refers to the curvature or asymmetry of an airfoil's shape. It determines how the air flows over the wing and affects the lift generated by the wing. In the context of a glider, the wing is designed to generate lift with the least amount of drag possible. To achieve this, glider wings often feature a specific amount of camber. The camber is typically designed to be greater on the upper surface of the wing compared to the lower surface. This design allows for a longer airflow path over the curved upper surface, resulting in lower pressure and higher velocity of the airflow. According to Bernoulli's principle, this pressure difference generates lift. By having greater camber on the upper surface, the glider can generate the necessary lift for flight while maintaining a streamlined and efficient airfoil shape. This design allows the glider to maximize its lift-to-drag ratio and improve overall performance. Therefore, stating that the camber is greater on the upper wing surface than on the lower surface of the wing is the generally true statement regarding wing camber of a glider's airfoil. 6623. When a slight upward or negative flap deflection is used, the result is A. Increased drag. B. Decreased drag. C. Decreased lift. The correct answer is B. When a slight upward or negative flap deflection is used, the result is decreased drag. Flaps are aerodynamic surfaces on the trailing edge of the wings that can be extended or deflected downward to modify the wing's shape and performance during different phases of flight. The deflection of flaps can have various effects on the aerodynamic characteristics of the aircraft. In the case of a slight upward or negative flap deflection, where the trailing edge of the flap is raised slightly, the primary effect is a decrease in drag. This is because the upward deflection changes the airflow pattern over the wing, reducing the pressure differential between the upper and lower surfaces of the wing. This reduction in pressure difference leads to a decrease in the aerodynamic drag experienced by the aircraft. While the decrease in drag is the main effect of a slight upward or negative flap deflection, it's important to note that it may also have some secondary effects. For example, it can result in a slight decrease in lift compared to the undeflected configuration, but this decrease is typically small and may not be significant for most flight conditions. Therefore, stating that a slight upward or negative flap deflection results in decreased drag is the correct answer. 6624. When a glider is turning in flight, the force that opposes the inward turning force is called A. Adverse yaw, B. Resultant force, C. Centrifugal force. The correct answer is C. When a glider is turning in flight, the force that opposes the inward turning force is called centrifugal force. Centrifugal force is an apparent force that acts outward on an object moving in a curved path. In the context of a glider turning in flight, the inward turning force is caused by the change in direction and the resulting centripetal force acting toward the center of the turn. This inward force is balanced by the centrifugal force acting outward, which is experienced by the pilot and the glider. Centrifugal force is proportional to the mass of the object and the square of its velocity. As the glider turns, the velocity of the aircraft increases, leading to an increase in the centrifugal force. This centrifugal force counteracts the inward turning force and helps maintain the glider's trajectory along the curved path of the turn. Adverse yaw is a phenomenon related to the differential drag experienced by the wings during aileron input. It is not directly related to opposing the inward turning force. Resultant force is a term that refers to the net force acting on an object, taking into account all the individual forces. While the resultant force may include the centrifugal force, it is not specific to opposing the inward turning force. Therefore, the correct answer is centrifugal force, which is the force that opposes the inward turning force during a glider's turn.